Water is everywhere. In fact, it covers nearly 3/4 of the Earth's surface, which makes you wonder why we call our planet Earth. Water comes in many different flavors. Sometimes it's fresh, most of it is salty, and in some places it's both. It can be as smooth as glass, fast-flowing, and often turbulent. Life as we know it began in the water, has emerged from it, and in some cases returned to it. Ships and boats transport products and people over its great oceanic expanses and inland waterways. Most importantly, however, in this story, it connects the land to the reefs. Georgia is a big state, the largest east of the mighty Mississippi River. It has mountains, plateaus in Piedmont, broad flat coastal plains, and barrier islands. It also has one of the largest cities in the country and one of the smallest protected reefs in the nation, and they are connected. Atlanta, the big, booming, busting at the seams capital city of Georgia, is connected by water to a fragile patch of live bottom habitat. Gray's Reef National Marine Sanctuary, some 270 miles away, rises from the ocean's sandy floor. Flowing through Georgia's heart is the Altamaha River watershed, the 7th largest watershed on the eastern seaboard. Water that perhaps fell as rain on Peachtree Street in the heart of Atlanta makes its way through farmlands, forests, and cities, past barrier islands to mingle with the salt of the ocean. It will eventually make its way offshore to wash over the undulating soft corals and oddly shaped sponges that grow on Gray's Reef rocky outcroppings and from its rippled sand bottom. The staff of Gray's Reef National Marine Sanctuary monitors the reef from their various research vessels. Most of the Gray's Reef staff are divers, and their job is to manage, monitor, and protect the reef. Gray's Reef is a part of the National Oceanic and Atmospheric Administration's National Marine Sanctuary Program and is one of 13 marine sanctuaries presently in the system. The staff works together with scientists from other agencies to review the information necessary to make management decisions that will maintain the health of the reef for generations to come. One area that deserves their attention is the health of the water that bathes the reef. Dr. Jack Blanton of the Skidaway Institute of Oceanography in Savannah, Georgia, studies the influence of the watershed on Georgia's coastal waters.
Georgia particularly has two rather large rivers, the Savannah and the Altamaha. The Altamaha actually is a little larger. And these exert a lot of pressure on the nearshore waters. And actually they tend to want to flow out across the continental shelf. But because the Earth is rotating, without any other forces acting, they want to turn to the right and actually flow south toward Florida. The Altamaha actually sends a rather large plume of fresh water toward Florida. But it doesn't take much wind blowing opposite that current to actually spread it far out into the continental shelf. I would say well past Gray's Reef. And of course it's diluted. When I mean diluted, it might not be, rather brackish water like we find in the estuaries. By that time it looks like low salinity ocean water. But the wind is everything. If the wind blows down the current like it does like through a northeaster, then it is very narrow ribbon of water well inside Gray's Reef. It goes all the way to Florida. And we've been able to trace this kind of movement mainly with Savannah River water because it has a radioactive tracer in it called tritium in very low concentrations. It's very expensive to analyze for it, but it does sort of tell the story. We have dilute tritium, which is Savannah River water, far out into the shelf, but that's usually been because the wind has blown against that southward flowing current and spread it offshore.
Gray's Reef is a fantastic underwater resource that is influenced by many different factors. And for the reef to remain healthy, the water from both land and sea must be clean. In the next hour, we'll explore Gray's Reef in the context that it's actually part of a much larger system, a system that begins on land, deep in the heart of Georgia, and extends all the way out to the continental slope. The Altamaha River watershed has its beginnings in the upper Piedmont, just below the mountains in the northern part of the state. The headwaters arise out of the counties of Fulton, DeKalb, and Gwinnett, some of the most densely populated areas in the state. These counties host the urban sprawl of Atlanta. Just outside the city limits of Atlanta, small creeks from other areas feed into larger ones and eventually commingle to form the South River. The South, in turn, joins two other rivers, the Yellow and the Alcovy, both arising out of one of the most rapidly growing counties in the nation. In Gwinnett County, housing costs are high and the supply limited. Here, neighborhoods spring up quickly like the gold rush boom towns of the Old West. Rain washes the top layers of dirt off newly cleared lots that won't have grassy lawns for months. The loose dirt and anything else the rain picks up is suspended in the muddy water of the drainage ditches, which eventually seep into the watershed. About 40 miles southeast of Atlanta, the South, Yellow, and Alcovy rivers converge to become the Ocmulgee River. The course of the Ocmulgee flows through farmlands. In the middle of Georgia's coastal plain, the Ocmulgee meets its counterpart, the Oconee, and like the Oconee drains the Piedmont. Just outside the city of Athens, home of the University of Georgia, the Oconee's two northern branches join. From here, the Oconee begins its journey southward, flowing through the eastern part of the Piedmont. It too passes through farmlands and through the 109,000 acres of the Oconee National Forest. Dams further downriver form two huge reservoirs, Lake Oconee and Lake Sinclair. Now nearly 80 miles from the coast, the Ocmulgee and the Oconee rivers join, giving life to the mighty Altamaha River. Lifelong resident, river advocate, and self-proclaimed river rat, Charlie Ford sees the Altamaha as the Indians did.
It wasn't the Oconee, the Ocmulgee, and then the formation of the Altamaha. It was just one long river. The word Altamaha means on the way to Tama. That is also from the Native American. The name is Native American. So that heritage in this region is somewhat been forgotten, but there's still remnants of it. We're reminded in the names, certainly, in the region.
These days, Charlie is concerned about some changes that have come to his river.
In all honesty, it's not always what you see that tells the true tale. It is what you don't see. And there are sources of pollution along the Altamaha that are just now being identified. We are working to pull these sources into regulation. Out here, it's primitive and it's pristine and it's isolated and beautiful.
The Altamaha River supplies fresh water, sediments, nutrients, and unfortunately pollutants to the coast. It contributes 1/6 of the total freshwater input to the South Atlantic continental shelf, as it drains more than 1/4 of Georgia's expansive landmass. It pumps on average 100,000 gallons of fresh water into the Atlantic Ocean every second. The Nature Conservancy of Georgia, in partnership with private landowners and forest industry corporations, has created the Altamaha River Bioreserve. Christy Lambert is the director.
The Nature Conservancy has defined 3 conservation goals for the Altamaha River system. One of them focuses on the protection of the hydrology, and that includes the water quantity, the water quality, and also the flow regime. an additional goal is to protect the contiguous floodplain. The Altamaha River system has this expansive floodplain. It's approximately 90 miles long and up to 6 miles wide. And we're working along the floodplain with landowners to help conserve the floodplain. And we also have one of our conservation goals is to protect the rare species and rare natural communities or habitats that occur all along the Altamaha River system. There are more than 100 rare species that are found in the lower Altamaha River system alone. And it's very interesting. They range from aquatic species such as the endemic mussels to very dry upland species and communities such as the longleaf pine ecosystem. We're working with landowners throughout the Altamaha River system with many different methods to try and conserve these rare species and lands.
For the most part, the Altamaha River is a pristine wilderness, one of the nation's last best places, according to the Nature Conservancy. There are only a few signs of human habitation along its path. There is one large industry situated on its bank that looms large. Near Doctortown, just below the Highway 84 bridge, sits Rayonier. The mill's huge digester crushes wood chips and chemically processes them to eventually make paper products. The plant takes approximately 50 million gallons of clean water out of the aquifer every day. Gerald DeWitt of Rayonier monitors the wastewater, or effluent.
Once the water is discharged from the mill as an effluent wastewater, we send it first through primary treatment. That's for the removal of solids. We take out about 90% of all the solids that's in the wastewater. Then we send it to aerated stabilization, secondary treatment. It has about 15 days of treatment in our aeration lagoons where we add nutrients to it and oxygen and allow the bacteria that are present to consume the food value of the waste. At that point we discharge it to the receiving water. We will have removed something better than 90% of the biochemical oxygen demand, the food value of the wastewater before we discharge it. Rayonier's use of pulping chemicals is so well managed that in fact if you look at the effect on the receiving water and the issue of aquatic toxicity, that is whether or not organisms in the receiving water would be adversely affected by some toxic effect of our effluent, Rayonier has never failed one of those tests. What the public expects and what we expect of ourselves has changed and will continue to change, and we expect to try to stay ahead of that curve and provide leadership.
Below Rayonier, the Altamaha twists and curves its way towards the coast. The large sandbars and high steep bluffs give way to seemingly bankless edges lined with tall cattails, asters, and duck potato flowers. Eventually, the Altamaha's fresh water flows into the ocean's salty surge. Where the fresh water from the rivers meet the salt water of the ocean, an estuary is formed. It quite literally creates a rich nutrient soup that feeds the marshes. The broth of this vital soup is referred to as brackish because it's a blend of fresh and salt water. This brackish soup nourishes the vast estuary, the habitat of the all-important salt marsh grass, Spartina alterniflora. Because the Georgia coast curves so far inland, it creates a funnel effect that channels the ocean water brought in by high tides onto the low-lying land. The result is that Georgia's coast boasts over 378,000 acres of beautiful green salt marsh. These vast grassy expanses are among the most productive acreages on Earth. From an osprey's winged viewpoint, the estuary between Sapelo Island and Little St. Simon's Island looks like vibrant green skin with dark veins of nutrient-rich water coursing through it. Many of the fish and invertebrates that inhabit Gray's Reef some 20 miles offshore begin life in the estuaries and marshes as larvae. Here they are protected and have a readily available food source. The marsh is their nursery. Just like the herons and egrets, raccoons and otters, humans tap this abundant resource as well. Crabbers make their living from the estuaries and marsh, with their traps strategically placed in the best creeks. Because there is so much marsh in Georgia, There is an abundance of sea life. More than 75% of the seafood we eat depend on the estuaries, and in particular the marsh, at some point in their life cycle. The delicious blue crab is perhaps the best known and the most sought-after marsh creature. Crabbers know firsthand how the water from land and sea affects the health of the estuaries and the animals that live there, especially the blue crabs.
The main problem with what we're seeing on the crabs today is that it's not natural. It doesn't ordinarily attack live animals. And in a case like that, when you find that they're attacking the live animals, there's a breakdown. And generally speaking, for animals that live in the water, it would be water stressors, or in other words, overloading with nutrients, low dissolved oxygen, that type thing. And when you find this situation, a crab's natural immune system is, generally speaking, it's like on fish, it'll be a thin layer of slime like on the outside of its body. And then when they're cannibalistic, and when they may fight one another, and then they become scratched, and this gives the chitin an opportunity to attack this crab at this particular point because it's lost its immune system, and that's where it attacks at that point.
Robert's family was in the oyster industry before turning to crabbing.
If you ride the Georgia coast, you'll see acres and acres of oysters. Most people think we still have plenty of oysters. We have plenty of junk oysters that are non-marketable. Reason being is the two protozoans, Dermo and MSX. Both of them attack oysters in high saline waters, and both of them will kill an oyster within about a year and a half of its life. It takes 3 years in Georgia waters to reach market size, so we never can grow a marketable size oyster. So we're on the same sharp decline as the oyster industry was 25 years ago, and it's for the same reason. We have another protozoan in the water, which all are natural in nature. They're just out of control, caused by high saline waters, and this protozoan is Hematodinium. It actually attacks the blood of the crab, and the crabs in a form or fashion suffocates. And it has been documented in the estuarine systems of Georgia have been as high as 83% contamination in the crabs. So we're again down the same slippery slope of another seafood commercial industry collapsing, and they will never return unless we can get the brackish water flow back to this coast. We used to have some of the most pristine, intact swamps of any state on the eastern seaboard. By the graces of the Corps engineer and legal means, the timber industry through 1987 could actually ditch and drain these dismal swamps legally to plant row crop pines. If you were a kid in Georgia in the 50s and 60s, you didn't see pine plantations like you do today. We have got every inch of available ground ditched, furred, and planted in pines. And by the increased production of pine and paper industries, we have ruined our coastal ecosystem by draining our swamps.
The estuaries and marshes are important in many ways. They are producers of food, filters of pollution, buffers against storm waves and tidal surges, as well as recreation destinations for tourists that generate millions of dollars for local economies. While James and Robert's livelihoods depend on the health of the marsh, the health of the entire coastal area offshore to Gray's Reef is dependent on the right amount of clean water coming from land and from the ocean. The Altamaha River watershed not only brings life-giving fresh water to the coastal area, but it gives life to the islands. The dark, muddy water transports the very building blocks that eventually form into islands. Every second, tons of sand and silt and clay pass through the mouth of the Altamaha into the sea. Sand grains that are relatively larger and heavier than the other sediments fall out of the water column in and around the mouth of the river. This sand creates bars that feed the islands. Moved around by the wind and water, the sand is pushed up into ridges that parallel the beach. These sand ridges, called dunes, in time support various grasses and vines and the vital sea oats, which are the most important plant for stabilizing the dunes. Eventually, the dunes support bushes and shrubs, and in time, trees that ultimately become forests. Pine forests are the first to be established, and as long as lightning-triggered fire sweeps through, the forest remains as is. If over a 5-year period fire does not clear out the low growth, the pines will be outcompeted by broad-leaved hardwood trees like live oaks. Sapelo Island and all of Georgia's barrier islands have beautiful forests of majestic live oaks, stately pines, and bushy-topped palms. These trees are the primary trees of Georgia's barrier island forests. Throughout the forest, the long gravity-defying branches of the live oaks reach inland like imploring arms. Their thick canopy, pruned by the salty mist from the sea, creates a cathedral-like sanctuary that bathes the forest floor in soft, filtered light. These are truly the magnificent maritime forests. The forests of these barrier islands, and in particular Sapelo Island, have been studied by Dr. John Averett of Georgia Southern University.
Well, part of it is this dune stabilization. The islands are important to protect the mainland from storms. And on the back sides of these dunes, there's a pretty good live oak population. There actually are 2 species on the backs of the dunes. But on into the interior of the island, they're important because of wildlife habitat in particular. They produce large crops of acorns that are important to different animals, turkey and deer in particular, and a lot of the non-game species as well. I think there are about 47 birds that use this maritime forest as a principal habitat, at least for part of the year.
Island forests have both tropical and temperate characteristics, sort of like a cross between the forest of the Florida Keys and those of Georgia's mountains. This blend of tropical and temperate is referred to as subtropical. These subtropical island forests support a host of animals, from beautiful butterflies and birds of all feathers to graceful white-tailed deer. High up in the thick green canopy, ospreys and American bald eagles build substantial nests. These birds of prey will frequently visit the nearby waters of the Altamaha River and the Atlantic Ocean for fish. Some of the fish these birds eat spend their days as juveniles upriver and as adults on Gray's Reef some 20 miles offshore. Sapelo Island is one of 13 major barrier islands that make up Georgia's wild archipelago. Its beaches are long and broad and very inviting. Daily tides and prevailing currents move the sand from bars that form just offshore of the beach and back again depending on the season. In summer, the sandbars are small, with most of their sand pushed inshore by the prevailing southeasterlies. The summer beaches of the barrier islands, and in particular Sapelo Island's beach, are broad and gently sloping. In the winter, the fierce northeasters send rough waves crashing ashore, scooping away the sand like giant shovels. The winter beaches are narrow and steeply sloped, while the offshore bar grows in size. During the summer months, the beaches and their hill-like dunes become nurseries for giant loggerhead sea turtles and various shorebirds. While the big sea turtles take an hour or so to dig their deep nests that will hold an average of 125 eggs each, the smaller shorebirds take just a few minutes to scratch out shallow depressions called scrapes for their nests. The scrapes will hold just a few eggs. The 2 to 4 eggs are more pointed on one end, so they'll roll in a circle if caught by the wind. Some of the loggerhead sea turtles that nest on Sapelo's beaches may spend some of their time at Gray's Reef, resting and foraging under the ledges. Rarely resting on the surface, the birds search from the air for unsuspecting fish below. At the mouth of the Altamaha River sprawls an extensive delta. Just south of the delta, Little St. Simon's Island, also one of Georgia's barrier islands, has added to its main beach at an amazing rate, while most others seem to be losing theirs. The amount of sediments coming out of the Altamaha is so abundant that as the sea level rises, the ocean literally pushes the sand before it like a powerful bulldozer. Hungry shorebirds waiting on the north beach of Little St. Simon's Island seem to know the minute the ebbing tide will expose the sandbars of the Altamaha's delta. An inch at a time, the sand flats are revealed as the water retreats back out to sea. The birds in dense flocks vie for any exposed patch where their beaks can probe for minute shrimp-like prey. Mostly, however, they're gobbling up the small clams called dwarf surf clams that congregate in the sand. During the summer months, the isolated sandbars and low-lying islands become noisy nurseries for thousands of brown pelicans, several species of terns and gulls that make their nests safely on the sand. Brad Wynn of the Georgia Department of Natural Resources has been studying these hungry migrating birds that stop to eat and those that nest on the Altamaha River Delta.
The Altamaha River not only supplies the sand we're standing on, but the fresh water coming down here and mixing with the salt water of the ocean creates a very rich estuary that produces the fish that the birds that are nesting on the sand depend on to feed their young on the beaches out here. And so, all told, it's a very rich site, a combination of a rich feeding source and protected nesting sites create the value for these birds, and that's why we have so many of them here. We have about 2,000 to 3,000 pairs of brown pelicans annually out here, and between 8,000 and 9,000 pairs of royal terns, which create one of the largest seabird colonies in the southeastern U.S., and we're protecting it from people. This island is closed year-round. It's also closed in the wintertime when we have sensitive bird species here overwintering. Piping plovers are an endangered species, and we have large numbers of those in the mouth of the Altamaha River.
Sapelo Island National Estuarine Research Reserve, known to most as just Sapelo Island, is managed by the Georgia Department of Natural Resources and receives support from the National Oceanic and Atmospheric Administration, better known as NOAA. Sapelo Island has many dedicated and knowledgeable people that work hard to ensure its environmental health as well as to preserve its history. Buddy Sullivan is the manager of Sapelo Island National Estuarine Research Reserve. He is also the leading authority on coastal Georgia's cultural history.
Sapelo became cultivated beginning in 1803 with the arrival of Thomas Spaulding as the plantation owner and manager of the island. And over a period of about 40 years, probably 2/3 of Sapelo was cleared for cultivation. Thomas Spaulding, like a lot of his contemporaries, cut live oak timber as he cleared his cotton fields and sold the live oak timber to shipbuilders from up north. This was one of the main ways of gathering timber for the shipbuilding interests in the north, as well as the United States Navy, which of course was constructing wooden warships during the early 1800s, and Georgia and South Carolina live oak was in great demand. So as Spaulding cleared his fields to cultivate cotton and sugar cane, he cut the live oak and sold it to the shipbuilders, and so he had sort of had a dual operation going at one time. During the war, the 4 years of the Civil War, most of Sapelo was largely abandoned. The fields lay fallow, and the agricultural operations completely were suspended. After the Civil War was over, the family began to return, as did many of the former slaves, who are now, of course, freed persons. And the Spaulding family began to try to recultivate cotton and other crops on Sapelo with the assistance of the former slaves on the island. As time went along, though, these operations were unsuccessful. Cotton was not a successful crop after the war, nearly to the degree that it had been before the war. As a consequence of that, people began to turn to other ways of making a living.
While Buddy is the recorder of the stories, Cornelia Bailey Walker lives the stories and tells them about herself and her people. She was born and raised on Sapelo Island in an area called Bell Marsh. When she was still a child, she moved to the community of Hog Hammock, where she watched Alan Green make sweetgrass baskets and her father, Hicks Walker, make cast nets. Having lived all of her life on the island, she never really thought much about the connection of the river to the ocean while growing up.
Papa's the one that went everywhere, so that's it, because Mama, didn't know nothing about the Altamaha, but Papa did, because he'd leave from home and he would go logging and fishing, so he did a lot of stuff. And the old barge trip, he used to work on those that goes up the Altamaha to do different things when he used to work for Howard Coffin and so forth. So Papa knew of the Altamaha, and so when fishing would get bad and stuff, and he said we're getting too much freshes, and it's coming from the Altamaha, and that's what's running the fish out of the areas when you can't catch a fish and you cast net or on the line or anything. He says too much fresh is coming in, and that's why we can't catch, any fish. And sometimes when it rains a lot, he also said there's too much fresh water going into the salt water, and that's creating a havoc on the fish and the oyster beds. Because they talk about the oyster beds being so plentiful during the 20s when our oyster factory was here, and you could gather oysters, and they canned oysters here and shipped it everywhere. And too much freshness started coming in, and the oyster beds started dying. And so we lost that industry, as well as even privately collecting oysters now is hard to do because of the fresh water and what it did.
The coastal waters that lie beyond the barrier islands and extend over the continental shelf contain the greatest abundance and diversity of sea life. Commercial fishing boats trawl these productive waters for shrimp, menhaden, and porgy. Charter fishing boats go after many different species of fish according to the season. Some of the favorites are kingfish, groupers, and snappers. Charter captains work hard to get their clients to the best fishing spots. Captain Judy Helmy of Wilmington Island near Savannah has been fishing Georgia's coastal waters for over 35 years.
It's very precious for number one because it's the only live bottom that we have that's very close to the coast. And it is very accessible to boats, being so close to Sapelo Island, only 18 miles, because actually our hard bottom area that we fish in the charter boat business is actually 25 to 35 miles offshore. Hard bottom areas or live bottom areas are much more enriched with fish population because they have this system going around year round, not like the artificial reefs that we have that only have migrating fish to them on certain times of the year. So Gray's Reef offers a great potential for everybody.
Many of the fish anglers catch spend their days as juveniles in the fresher inland waters, moving to deeper, saltier waters as adults. The sheepshead is one such fish. Some of the black-barred sheepsheads spawn at Gray's Reef and move closer inshore to lay their eggs. Newly hatched sheepshead feed and find protection in the nutrient-rich coastal and estuarine waters. Sometime in the first few years of their lives, they leave the relatively protected inshore waters for deeper waters offshore until they're ready to spawn. If they're lucky enough to avoid the jaws of larger predators and a hook, they might survive to a ripe old age. Trick is not to get caught. For most of the 80 miles of continental shelf off Georgia's coast, the water is fairly shallow, at less than 100 feet. At its outer edge, the depths dip to just shy of 200 feet. Beyond that, the continental slope plunges approximately 3,000 feet before leveling out onto the Blake Plateau. Closer to land, offshore of Sapelo Island, Gray's Reef's dazzling formations thrive in 60 to 70 feet of sea-green ocean water. It takes the staff about 5 hours to make the trip from their dock in Savannah to the reef proper aboard their NOAA research vessel, Jane Yarn. On other sanctuary vessels, the trip can be as short as an hour and a half on a calm day. While at the reef, the staff will dive several times each day to do fish counts and to monitor the reef communities by taking underwater photos and video footage. These film and video records help them observe changes that occur on the reef over a period of weeks, seasons, and even years. The staff employs the latest technology to help them assess the reef's complex communities. The trip out to the reef is fun most of the time, with lots of sea creatures to watch. The thought of getting seasick is put on the back burner once dolphins are noticed riding the bow waves. On nearly every trip to the reef, bottlenose and spotted dolphins rocket in front of the ship's bow, knifing through the waves like fleshy torpedoes. Small, oily, open ocean birds and large gull-like birds called gannets patrol the waters on wing for unsuspecting fish schooling at the surface. From a boat or an airplane, the most noticeable clue that you are even near Gray's Reef is NOAA's yellow weather data buoy anchored in the middle of the sanctuary, or the smaller buoys that mark the four corners. On weekends, when the weather is good, boats filled with recreational anglers surround NOAA's weather data buoy. The other tip is the incredible concentration of Atlantic thread herrings and Spanish sardines that move in large shape-shifting schools near the surface. From above, noisy seabirds skillfully plunge into the water in hopes of securing dinner. Loggerhead sea turtles with large chestnut-brown shells surface to catch their breaths and to take a look. 70 feet down, however, it's another world. The waters of the Altamaha River watershed are critical to the fragile ecological balance of the coast. In an effort to understand this system a bit better, and to understand how it affects our precious live bottom reefs better, the staff and other collaborating scientists monitor Gray's Reef. Through fish counts, water quality monitoring, anchor damage assessments, invertebrate monitoring, and surveying the entire bottom, various teams determine the state of the reef and identify areas that need better protection. Greg McFall is the research coordinator for Gray's Reef National Marine Sanctuary. Recently, research has revealed new information about the fish at Gray's Reef.
We've been studying the fishes at Gray's Reef to try to determine how many species spawn there. In the investigations that we've conducted, we found that around 33 species spawn in Gray's Reef.
Greg and his colleagues are concerned about contaminants coming from the Altamaha River watershed that make their way out to the reef.
Once the contaminants arrive at Gray's Reef, they're often contained in the sediment that we find in the sand. And we have a lot of small organisms, we call them benthic infauna, that live in the sand. These could be small worms or mollusks, and they often eat the organic material that's in the sand. In the process of eating, they pick up these contaminants, or can pick them up, and they stay in their bodies. When a fish comes along and eats the invertebrates, those contaminants can then be transferred to the smaller fishes. In that manner, the contaminants can find their way through the food chain out at Gray's Reef.
Once a suitable site has been found, divers take the plunge, anticipating the amazing wonderland of colors and shapes. As they descend the jade-colored water column, they equalize the pressure building in their ears. 20 feet down, the bottom appears hazy, but the closer they get, the clearer it becomes, revealing a beautiful sandstone ledge encrusted with colorful sponges and soft, supple corals. The sandstone outcroppings and ledges of Gray's Reef support a fantastic array of marine life. Wide-mouthed bay sponges, branched sea whips, spindly-legged arrow crabs, and silvery round and mackerel scad provide food and refuge for grouper and bass. Top predators like king mackerel, amberjacks, and barracudas patrol nearby, sizing up potential meals. Occasionally, manta rays make an appearance, gliding majestically over the reef as if surveying their kingdom to make sure all is well. The encrusting colonial animals are sustained by the nutrients brought from land by the freshwater rivers and from the ocean by salty currents and tides. They, in turn, support the many different species of fish that patrol the waters just above the ledges and those that find safe hiding spots underneath. Nurse sharks, as well as loggerhead sea turtles, can both be found resting under the ledges or searching for their preferred food of shellfish. While diving is the preferred way to make first-hand observations of the reef, sometimes that's just not possible. Fortunately, there are other ways to explore the ocean bottoms. Remotely operated vehicles called ROVs and submersibles help the staff explore areas too deep or too vast for divers. ROVs house cameras that send back images to a television monitor inside the ship's lab. Pilots operate the toggle switches and joysticks on the control panel to steer it up and down, left and right, and even propel it forwards and backwards. The trick is to keep it near the bottom without actually hitting anything. ROVs are worth their weight in gold in unfamiliar areas and in depths too great. The wrecks of the famous Titanic, the historic Monitor, and many others have been explored with ROVs, revealing secrets that have been buried in the sea for decades and in some cases thousands of years. Submersibles that hold from 1 to 4 help researchers make observations almost as good as if they were diving, and in some cases even better. Submersibles like the one-person Deep Worker 2000 are used to help researchers characterize and explore each site in depth, so to speak. These submersibles have been used in many missions that have studied sites in all of the national marine sanctuaries. One mission called Sustainable Seas Expeditions was led by Chief Scientist Dr. Sylvia Earle, who was also one of National Geographic's explorers in residence. This particular mission trained many researchers to pilot Deep Worker 2000. Her goal was to promote the sanctuaries through the research and explorations conducted by the pilots. The small one-person submersible is capable of reaching depths of 2,000 feet. At Gray's Reef, however, the pilots explore at only 70 feet. The advantage of using a submersible at the relatively shallow depths of Gray's Reef is that the pilots can stay underwater for up to 4 hours in the sub. Any longer than that during the summer, when the sea conditions are the best, the heat inside could become a problem in the 85-degree Fahrenheit water. High-tech cameras help the pilots record fish, survey the bottom, explore new areas, and make observations from the relative comfort and safety of their tiny enclosure. At night, the lights of the sub attract an array of small fish and larval sea creatures. Pilots inside the sub maintain contact with the chase boat and mothership via radios designed to transmit through the water. Pilots also record their observations on a tape recorder inside the sub, while cameras attached to the outside capture the creatures of the reef. Researchers use other technology to explore the ocean and its processes. On several towers east of Gray's Reef, the SABSOON project has installed an impressive array of instruments. SABSOON is an acronym that stands for South Atlantic Bight Synoptic Offshore Observational Network. It's just much easier to say SABSOON. SABSOON was developed by the Office of Naval Research with several partners like Skidaway Institute of Oceanography, University of North Carolina, and South Carolina Department of Natural Resources to provide a range of information about ocean currents and conditions, as well as offshore weather. The information is transmitted back to land on a continuous real-time basis. Underwater cameras have transmitted images of fish, turtles, and even birds diving at the base of the towers. Archived and real-time data may be used by weather forecasters, mariners, and resource managers for regional management decisions. Due east of Gray's Reef in deeper waters lies two prominent and important features of the continental shelf known as the Savannah Scarp and the Charleston Bump. These features were explored during another mission of exploration in which Gray's Reef staff participated. Islands in the Stream South Atlantic Bight mission was sponsored by NOAA's Office of Ocean Exploration and by NOAA's National Marine Sanctuary Program. NOAA, or National Oceanic and Atmospheric Administration, is keenly aware that the oceans are the last frontiers on Earth and that relatively little is known about them. In fact, in this latest age of exploration and discovery, we know more about the geography of the dark side of the moon and the surfaces of some planets than we do of the bottom features of our greatest ecosystem on Earth, our own vast liquidscapes, our oceans. Reed Boney has been the sanctuary manager of Gray's Reef National Marine Sanctuary since 1990. He sees how Gray's Reef is connected to other formations on the outer reaches of the continental shelf.
You have to understand what the influences are from the coast and what's happening offshore. And that's where our science becomes so critical. We can't just do research in Gray's Reef and feel we understand it well enough to manage it effectively. That's why our participation in projects like Sustainable Seas and the Islands in the Stream project that are looking at key areas both inshore and much further offshore are so important to us. And that's why our staff and the researchers from the region get involved in not only projects at Gray's Reef, but projects that take us far afield. It's only that way that we're going to really understand what's happening at Gray's Reef.
Through missions like Islands in the Stream South Atlantic Bight, scientists and support staff are exploring at great depths and observing unique sea creatures and ocean bottom features. During the first season of Islands in the Stream South Atlantic Bight, Savannah Scarp and Charleston Bump were explored. Dr. George Sedberry was particularly interested in the reef formations at the edge of the continental shelf.
This reef habitat that occurs off the southeast coast is not distributed over the entire continental shelf. It's very patchy on the continental shelf, and here at the shelf edge, it's concentrated. There's more or less a discontinuous ribbon of reef habitat that occurs from North Carolina down into Florida.
Scientists use traditional methods to sample, collect, and study, with nets, traps, and tags. They explored the ocean bottoms with various ROVs and submersibles named Clelia and Johnson Sea Link. The 3- and 4-person submersibles from Harbor Branch Oceanographic Institution are capable of reaching depths up to 3,000 feet. Savannah Scarp on the edge of the continental shelf consists of low-relief rocky outcrops and ledges situated in about 200 feet of water. Even though the relief is relatively low and offers few hiding places for sea creatures, explorers did discover that fish and invertebrates were abundant nonetheless. Mottled octopus moving along the bottom were either in search of food or perhaps just curious about the submersible. Frilly beige seahorses hiding in the branches of soft corals brought up in special tanks were studied for proper identification. Because Savannah Scarp is directly influenced by the Gulf Stream, invertebrate and vertebrate communities here are a bit different from the ones that can be found at Gray's Reef, which is out of the direct influence of the Gulf Stream. The evenly spaced white dots on the scales of a snowy grouper look as if an artist painted them there. They are, however, real and help the grouper survive. Just exactly how they help is perhaps one of the many discoveries scientists on future missions will make. Further along the path of the fast-flowing, salty, warm waters of the Gulf Stream, the popular fishing grounds known as the Charleston Bump rises from the depths to some 1,200 feet below the surface. Video footage shot by scientists in the subs record the depth in feet, the temperatures in centigrade, and the salinity in parts per thousand. Also in the footage, 2 bright spots of red light spaced at a typical distance of 8 inches apart provide a measurement reference to determine space or size. The bump, as it is referred to, deflects the path of the Gulf Stream to the northeast. It's located on the northern end of the deep lake plateau that ranges in depth from 1,500 feet to nearly 3,300 and stretches from the edge of the continental shelf up to 300 nautical miles seaward. The bump is a landward rise of the Blake Plateau that creates a bathymetric or ocean bottom barrier to the flow of the Gulf Stream. It was created several 100 million years ago when the continents broke apart. It became a barrier to the Gulf Stream soon after. The side receiving the brunt of the current from the Gulf Stream is the most scoured. The stream has eroded and sculpted the sea floor to form habitats for large wreck fish as well as other fish like anglerfish, black-belly rosefish, and the short-nosed green-eye. Of course, the sculpted bottom also provides plenty of places for invertebrates, such as soft corals and crabs, to find their own places to investigate and in some cases attach. Flying through scenes that look like they might be in a snow globe paperweight that someone has just turned over a few times, the subs enable scientists to observe the benthic or bottom creatures in their own habitats under pressures too great for a human to dive safely. By studying organisms in their natural surroundings, scientists can understand where they fit in and how they relate to the other organisms sharing those same habitats. Creatures at these depths of 1,500 feet and deeper endure pressures some 50 times greater than creatures at the surface, but they're well suited to their life under pressure. Their odd shapes and body configurations help them succeed in their deep, dark, watery world. Even though no light penetrates the bottoms at these depths, lights from the subs reveal their lovely shades of reds and oranges. Because red and orange are the longest waves in the spectrum of white light, they're the first to be filtered out in the water column at around 35 feet. So then, why do many of these fish sport those colors at these depths? Apparently, it's a matter of survival. The eyes of these benthic creatures detect differences that human eyes cannot. The principle, however, remains the same. If a fish can remain successfully hidden, it can avoid being discovered and eaten, or it can lay in wait undetected to pounce on potential prey. Sometimes it's necessary to investigate a fish or an anemone closely, and the sub is equipped to do just that. By using the robotic arm of the sub, scientists can pluck soft corals from the bottom for closer inspection and identification back at the surface. They can also engage a suction tube to take samples of the bottom sediments for later analysis at the surface as well. By exploring and investigating these fantastic deep ocean habitats, we'll know what they're made of, what creatures and plants use them, and how they're connected to the rest of the reefs and other ocean bottom geologic formations. This knowledge is key to helping us understand what they are, what they do, and most importantly, how we influence them. Researcher Henry Ainsley understands the greater importance of these missions.
The type of information, in order to go with marine protected areas, it's very hard to put a place on the map and say, here, if you want them to work, you're obviously going to have to put them in the right place, and this is the type of information that's vital for setting these areas up. And if we don't get this information, you won't give the concept a chance to work.
For the long term, we need to know how we affect them and what we can do to protect them, because like all things in this world, they're connected to everything else, and in the end, we are connected to them all. People who dive and fish Gray's Reef, and especially the sanctuary staff, thrill to its diverse abundance of life, but they're also mindful of the precarious balance between healthy sustained use and overuse. They know that the ecological health of our entire state and ultimately its people are dependent on the well-being of each of its individual parts. Gray's Reef is only one small link in the long chain that connects land to sea, rivers to reefs. But it is certainly a crucial link. It is a beautiful garden spot connected to the vast Altamaha River watershed, a system that begins in the heart of Georgia and works its way to the coast, spilling offshore over the continental shelf. Gray's Reef National Marine Sanctuary is an eye-pleasing oasis of phenomenal splendor, a national treasure worthy of our continued protection and in need of our vigilance.